this is the last thing we talk about sulfur trioxide. I'm going to look at the sulfite ion. Okay, so I'm going to erase part of this. I want to keep most of it, right? I'm going to take this out because I'm going to need the space. But we're keeping this. This is the general structure of sulfur trioxide. And now we're going to make this an ion. What happens when we make an ion? And it's actually kind of interesting. The first thing you probably want to get rid of is a double bond. Okay? We're going to lose double bonds as we add electrons. So once again, it's SO3, and a sulfite ion has a charge of -2. So before I said we had 24 electrons, now we have 26 electrons, right? So in that being the case, we have 2 more we got to stick on this. And we know it's going to be a charged molecule. Right here it's 0, but there's going to be a charge in here, right? Who do you think should get the charge? I'll give you a hint. It's right here. It's the electronegative one. He's going to want the electron more than sulfur, right? So oxygen is going to be the winner in that battle, right? So taking a look at this, let's move one of these double bonds off. Let's make it happen. So how would I do this? Well, let's just redraw this thing, okay? This is what should be here. And if we drew it again, sulfur, oxygen, 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 and let's sprinkle them on. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And of course 1, 2, 3, 4, 5, 6. Okay? So now we have 24 electrons showing, and we put 2 more here. 1, 2. Okay? If we look at it like this, 1, 2, 3, 4, 5, 6, 7, 8. And then we have 8 times 3, 24, plus 2 of them makes it 26. However, right, we got to think to ourselves, is this the way it would look? Right? Probably not. Why would this guy sit like this? We have other options we could do for making this look proper. Let's do a formal charge on this real quick and see what it looks like before we start dabbling, right? So we're going to still name them 1, 2, and 3. So 1, 2, 3, and sulfur in the middle. So it's SO1, O2, O3, and I'm going to put some lines on here. It's got to be a little tight towards the bottom, but we could do this. Let's do this. So valence, assigned, formal charge. Okay, down on the bottom. So let's try this one first. So valence for 6, 6, 6, 6. Assigned, how many do I have on sulfur? 1, 2, 3, 4, 5. All right. This guy is 1, 2, 3, 4, 5, 6, 7. 7, 7. Right? In the end, he gets a +2. Right? Oh, no, wait. 1, 2, 3, 4, 5. He has a +1. I screwed that up. He has a +1. -1, -1, -1. So our charge of this is -2. Okay? However, you got to ask yourself, is this the best? Is this the best we can do? And I say, once again, the molecule's going to want to reduce the amount of charge inside it. You say, well, it's a charged molecule. It's supposed to be -2. Well, it's going to try to still reduce the amount of internal charge. So we have another option, and we're going to go this way with it. So I'm going to have to erase this guy, a little bit of it. I'm going to take this out. I'm going to take this one out. Okay? And I am going to 2, 3, 4. I guess I could make this, because it's a little wacky now. Let's make this fit. All right. I guess I could just do this. I don't like the way to look. Put this here. Put this here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. All right. And let's count our electrons in this situation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Right? However, we're going to put 2 on this guy. Right? Let's do a head count. 1, 2, 3, 4, 5, 6. Okay. So let's look at what do we have assigned and what our charges is in these things. Once again, 1, 2, 3. Okay, we'll start with sulfur. 1, 2, 3, 4, 5, 6. 6, and we still have 6 on sulfur. His total charge is 0. Oxygen 1, 2, 3, 4, 5, 6. He's got 7. So his charge is -1. Oxygen 2 down here. 1, 2, 3. He's got 7. He's -1. And the last guy, 1, 2, 3, 4, 5, 6. He's got a 0. All right. So basically, we still get the charge. Oh, I got to clean this up because that's wrong. This is -2 because we've made it a charged molecule. This would probably, between the two, they could both happen, but this is probably more likely to occur because it has less of an internal charge and thing. It's going to have a charge because it is a sulfite ion. The whole thing has a charge of -2. But this, in a sense, we have the most negative ones are going to be on the oxygen like we expected it to be, right? However, we have 2 of them are kind of renders close to 0, which is kind of what we're kind of going for with this. I missed that 6. So that's another configuration.